I'm an astronomer. My name's Andrew Crommelin, and I was involved with Sir Arthur Eddington's solar eclipse observations.
What were you guys trying to find?
Well, we were trying to figure out who was right, Einstein or Newton. Newton's theory came a lot earlier, but Einstein recently came out with his general theory of relativity, and it made some pretty bold claims, so we went out to see if it was right.
Well, where did you go to see if this was right?
We went to Sobral, Brazil, and the island of Principle. We were going there so we could observe a solar eclipse. The solar eclipse was going to line up perfectly with a star constellation that was fairly bright. So our plan was we were going to measure the positions of the constellations before the eclipse and then compare that to positions after, because if those positions are different, this would imply an effect called gravitational lensing. And this would tell us who was right, Einstein or Newton.
Were there other significant events happening around the world at that time?
Well, World War I had just ended. That was probably the most significant, but I found out later that the pop-up toaster we all know and love, its patent was filed that day.
Was there anyone else involved with you in this project?
Sir Arthur Eddington was heavily involved. We were also sponsored by the Royal London Society. And I don't know if I mentioned, but we kind of set off on this adventure on, I think it was May 29th of 1919.
What was your role in the project?
Well, we had two teams. One went to Principal, the other went to Sobral. Eddington went to Principal, and I went to Sobral. So what we needed was two teams because we're looking at the sky, and if it happened to be cloudy during the totality of the eclipse, our measurements wouldn't be good. They wouldn't be accurate enough for us to use, because we're talking about some pretty small, minute differences. So I was the team leader for Sobral. It actually worked out well because the weather was kind of cloudy in Principle that day. They were able to get a few measurements as it cleared up later on, but we actually got a lot more conclusive measurements that were actually able to prove what we set out to prove. Funny story, actually. The telescopes we took were so big, and it was so hot down in Brazil that the metal actually like swelled, and we weren't able to use our large telescopes. We had to use the smallest one we brought with us. So that's kind of interesting fact.
What kind of impact do you think that your findings had on the physics community?
Well, like I said, there were two theories. Newton's classical mechanics and Einstein's general theory of relativity. Newton said that light would bend around an object, but he believed gravity was a force. So light wouldn't really bend because a photon didn't really have much mass, but he did predict it would bend. Einstein, however, thought it would bend double the amount Newton thought it would bend. And it's because Einstein's theory of relativity predicts a different kind of gravity. He doesn't believe in a gravitational force, but in gravity as a consequence of what he called space-time. He believed that the spatial dimensions and time was another dimension. There was a fabric, and then when mass was present, this would kind of depress the fabric of space-time. Imagine a bowling ball and a trampoline. And the photon would have no choice. It's traveling, just traveling. And then all of a sudden it has to dip down. And that's what the bending would be. So we needed to know who was right, Einstein or Newton, because Einstein's theory has some pretty large impacts. So it turns out that Einstein was actually right, because the positions were different. So that means that Newton's approximations, they were just too small for it to work. Einstein was right, otherwise we wouldn't have observed the gravitational lensing that we observed. So it's really, I guess to answer your question, it really turned the physics community on its head, because we proved this Swiss patent clerk had actually come up with a really redefining theory that changed how we thought about the universe that we thought we understood.
Amazing. The last question we have for you today. What do you think the biggest challenge of this project was for you and your group?
Well, like I mentioned, World War II hadn't happened yet. World War I had just ended. So this meant that our telescopes, believe it or not, they weren't that small. They're not like the ones that you look out your window with. They're pretty large things. And we needed factories to manufacture these in. But nobody's going to build you a telescope when they're busy building tanks. So we had to wait, and luckily the timeline worked out just right. They were able to make ours in last minute so we could take them on the expedition with us. Another really big challenge we had was communication and travel. See, we had to travel by boat, so had to leave days in advance. And traveling by boat with precision equipment isn't exactly easy. Also, once we left out, we were kind of on our own because we can't communicate across an ocean. So that's where the two team leaders really came in strong there.
Thank you for your time.
Thank you.